Section 3B.2 Older Brain Structures. What are the functions of important lower-level brain structures? If you could open the skull and look inside, the first thing you might note is the brain's size. In dinosaurs, the brain represents 1/100,000th of the body's weight. In whales, 1/10,000th. In elephants, 1/600th. In humans, 1/45th. It looks as though a principle is emerging, but read on. In mice, the brain is 1/40th of the body's weight, and in marmosets, 1/25th. So there are exceptions to the rule that the ratio of brain to body weight provides a clue to a species' intelligence. Indicators about an animal's capacities come from its brain structures. In primitive animals such as sharks, a not-so-complex brain primarily regulates basic survival functions: breathing, resting, and feeding. In lower mammals, such as rodents, a more complex brain enables emotion and greater memory. In advanced mammals, such as humans, a brain that processes more information enables foresight as well. This increasing complexity arises from new brain systems built on top of the old, much as the Earth's landscape covers the old with the new. Digging down, one discovers the fossil remnants of the past, brainstem components performing for us as much as they did for our distant ancestors. Let's start with the brain's basement and work up to the newer systems. Section 3B.2.1 The Brainstem. The brain's oldest and innermost region is the brainstem. It begins where the spinal cord swells slightly after entering the skull. This slight swelling is the medulla, figure 3.15. Here lie the controls for your heartbeat and breathing. Just above the medulla sits the pons, which helps coordinate movements. If a cat's brainstem is severed from the rest of the brain above it, the animal will still breathe and live, and even run, climb, and groom. Clem, 1990. But with its brainstem cut off from the brain's higher regions, the cat won't purposefully run or climb to get food. The brainstem is a crossover point where most nerves to and from each side of the brain connect with the body's opposite side. This peculiar cross-wiring is but one of the brain's many surprises. Inside the brainstem, between your ears, lies the reticular net-like formation, a finger-shaped network of neurons that extends from the spinal cord right up to the thalamus. As the spinal cord's sensory input travels up to the thalamus, some of it travels through the reticular formation, which filters incoming stimuli and relays important information to other areas of the brain. In 1949, Giuseppe Moruzzi and Horace Magoun discovered that electrically stimulating the reticular formation of a sleeping cat almost instantly produced an awake, alert animal. When Magoun severed a cat's reticular formation from higher brain regions without damaging the nearby sensory pathways, the effect was equally dramatic. The cat lapsed into a coma, from which it never awakened. Magoun could clap his hands by the cat's ear, even pinch it, still no response. The conclusion? The reticular formation is involved in arousal. Section 3B.2.2 The Thalamus. Sitting at the top of the brainstem is the thalamus, figure 3.15. This joined pair of egg-shaped structures acts as the brain's sensory switchboard. It receives information from all the senses except smell and routes it to the higher brain regions that deal with seeing, hearing, tasting, and touching. Think of the thalamus as being to sensory input what London is to England's trains, a hub through which traffic passes en route to various destinations. The thalamus also receives some of the higher brain's replies, which it then directs to the medulla and to the cerebellum. Section 3B.2.3 The Cerebellum. Extending from the rear of the brainstem is the baseball-sized cerebellum, meaning little brain, which is what its two wrinkled halves resemble, figure 3.16. As you will see in Unit 7A, the cerebellum enables one type of nonverbal learning and memory. It helps us judge time, modulate our emotions, and discriminate sounds and textures. Bauer and Parsons, 2003. It also coordinates voluntary movement with assistance from the pons. When soccer great David Beckham fires the ball into the net with a perfectly timed kick, Give his cerebellum some credit. If you injured your cerebellum, you would have difficulty walking, keeping your balance, or shaking hands. Your movements would be jerky and exaggerated. Under alcohol's influence on the cerebellum, walking may lack coordination, as many a driver has learned after being pulled over and given a roadside test. Consciousness is a small part of what the brain does. Neuroscientist Joseph Ledoux in Mastery of Emotions, 2006. Note, these older brain functions all occur without any conscious effort. This illustrates another of our recurring themes. Our brain processes most information outside of our awareness. We are aware of the results of our brain's labor, say our current visual experience, but not of how we construct the visual image. Likewise, whether we are asleep or awake, our brainstem manages its life-sustaining functions, freeing our newer brain regions to think, talk, dream, or savor a memory.